Okay, just to recap on where we're at. So we've... Okay, we talked about identification. We've already spoken a bit about acquisition of software, how do companies develop new products and everything, and we're back talking about how do they actually find technologies and everything that they're going to use. That's what we did last week, and we finished, and I just want to talk about this. I think called the technology S-curve. It's one of the the tools that's used for predicting technology. And it's used to show how a life cycle of a technology starts and continues and grows and then tapers off towards the end. And in terms of the technology management process, it's mainly used in identification, selection, and protection to a certain extent of technologies. So what I want to talk to you about today is this notion of the technology S-curve. At least that's one of the things. You might hand those out. That's just a description of technology S-curves. Pass those around. Okay. So typically, the S-curve is broken into 4, or very often you'll just see 3 phases on it there. A lot of people will just look at it in terms of, I can't even read my own writing. I'll go on to the next one and I'll see. A lot will just look at incubation, takeoff, and maturity, okay? But, I mean, you can break it down into 4 different things. So technologies typically start with a slow growth. So this is the amount of time that it's taken to develop a technology versus the improvement in performance, where a technology actually performs. And the way the S-curve works, or what it's used to predict, is that basically if you start off, and maybe the diagram here is slightly better, or maybe... Yeah, we'll use this one here. It's from one of the papers that's in the handout that I gave you. So typically at the start, if a new technology is emerging, you'll spend a lot of time in development before you actually get any progress. So there are a couple of, well, no, that's just showing limitations. So say if you're coming up with developing, maybe it's a new drug administering system, you might spend a lot of time in R&D and a lot of money and effort as well without actually getting something that works. So that's what that is showing there. When a technology starts off, there's a lot of development before you actually get something that works. Then once you make that breakthrough and get something that's actually working properly, you get rapid improvements in the technology as time goes on, until you exhaust or the technology limits out, and then again, as time moves on, there aren't many improvements in technologies. Could we think of any technologies that are at any stages there? Like, we probably don't know what's down here. You know, this is what's in R&D labs all around the world. This is what, was there an example? No, it wasn't on this one. No, this is on, I mean, there is an example, and just one of the websites I was looking for examples to back this up, about, no, actually, it's in your paper. It's in the paper here. If you look at down as far as, say paper number 10, about S-curves. Okay, so if you're on to section 10, where it's talking about technology S-curves, and if you just go to page 46 of that paper. And I haven't page numbers on this now, so you'll just have to go through it. So I'm looking for that page there. You got that page? Yeah, it's the next page over. No, maybe you're on the wrong paper. Go back. What paper is that? Oh, sorry. No, your pages are different from the way mine are there. Okay. So if you see the case just on the second page, it says a case in point would be Aventis collaboration with Harvard Medical School. So the goal of the collaboration is to identify new targets for oncology. So they're looking at working on cancer drugs. They're probably spending a lot of time down here trying out different technologies, trying out different types of drugs without actually getting something that works. Simply because once they get something that works and that it works in a way that you can actually commercialize it and have it available for mass production, then suddenly that technology will take off. So if out of that collaboration, and have a read of that in kind of when you're studying, just go through that, not necessarily the whole paper, but just that particular piece, kind of section 2 there, read through that because it's a good example. So they'll probably start, and this is kind of saying typically, certainly in the medical devices industry, that a lot at this stage, an awful lot of the work is being done by startup companies or within academia where they have the resources in different academic science labs. So they'll work for a long time on something and then it'll take off. Now again, this is for this particular industry, for the biotechnology industry. As something is taking off there, you'll typically have different forms of alliances. So very often in the medical devices and pharmaceutical industry, it's not always the big companies that develop a new technology. It's smaller companies that develop a new technology, and then the big companies will move in and either buy out that technology or have some form of an alliance with them to gain ownership or use of the technology. And it's at that point in time that you really see the technology taking off, and lots of developments as it develops. And then technologies kind of tend to limit, so you can only go so far with a particular technology or whatever it is, and it reaches the maturity stage, and then you don't see much of an increase in performance. What would happen then? What do you think would happen next after technology limits? If you're looking at... Well, yeah, it could decline, but typically what will happen is that another S-curve will start off. Okay, so for any, there are a couple of examples on the handout that I've given you. Now the handout, so the paper you have is kind of talking about technology S-curves in the pharmaceutical industry. The handout that I've given you here came from the NASA website, so it's talking about technology S-curves in transportation. And if you just have a look at the top of it there, it evolves, a given device or method will reach a point where it can no longer be improved. So for a particular type of technology, you've gone as far as you can go with that. And there are a couple of examples of that. So the limits of sailing ships were exceeded by steamships. So sailing ships, what do you think the performance criteria that you'd measure something like sailing ships against? Anybody? Because remember, on your S-curve, the two parameters are time and performance. So if you're using an S-curve to try and predict technology, you need to decide what performance criteria you're measuring. So for ships, what? Speed, absolutely, yeah. So what that is saying is that with a particular technology for ships, eventually there'll come a time where no matter what tweaking you do, you just can't get it to go any faster. And then a new technology will come over. So that's saying the limits of sailing ships were exceeded with steamships. So when sailing ships had gone as far as you could go with whatever design you were putting in there, then suddenly steamships were coming up. And very often the new technology won't start in terms of the performance. Have I a pen here? No, they probably aren't. No, I don't have a pen. So the new technology won't always start like you'd expect. If the performance of sailing ships was here, then steamships come along and it's going to lift the performance, so where it'll move on top of it. But that doesn't always happen. Sometimes a new technology will start off lower before you actually hit the improvements to start to pass out an existing technology. So you can see something that starts, in terms of speed, that initially when it's produced, the designers have problems in kind of matching what is the current speed. But because the technology is newer and has more potential, that as it goes through its S-curve, it will surpass the existing technology. And one of the things that companies try and do is that this gap between where the new technologies are coming out and where the existing mature technologies are, you don't want that to be too big, because if it is, then you have a lot of catch up before your new technology is actually making sense. So that kind of, in the handout that I've given here, I've given it to you because it was just simple and it gives a couple of examples. So speed limits of propeller aircraft were exceeded by jet aircraft. Altitude limits, so speed could be one performance criteria that you're looking at. But in the aircraft business, altitude is another performance criteria. So it says altitude limits of aircraft were exceeded by rockets. So no matter what you could do with an aircraft, you had got as far, you'd flown aircraft as high as you could possibly take them. So you had to look at a new technology, and the new technology was rockets. So we'll just go through this a little bit. So a breakthrough is when performance limits of an existing device are exceeded by a new or different device. And the key word is different. So it's a different technology that's coming along that exceeds the existing one. Just seeing, is there anything else there? Okay, so this breakthrough event, so the breakthrough is where you actually kind of move off your technology S-curve and start with a new technology, something that's different, and it takes over from there. Read that, because that kind of gives you an outline of what a technology S-curve is about and how it works. And as you can see, like, we have two good examples there. You have an example, and this came from a NASA website, which I've listed on the bottom, so go and have a look at that, because that'll be interesting enough to look at as well. S-curves will apply to any types of technology, and you'll see them in any types of technology. Our two examples are in biotechnology, pharmaceuticals, biomed, and the one we have here from NASA, which is in transport and air transport. And the same type of a framework can apply to both. Yeah, if you're actually putting together an S-curve, one of the key things you need to do is to look at what is the performance metric that you're actually building on. So in here we had two different performance metrics. One was speed, one was altitude. So if you're looking at kind of mapping a technology and seeing how it's performing in terms of the S-curve, you need to decide what is the metric. Can we talk about different technologies and what kind of metrics? What kind of metrics? Can anybody give me a couple of examples of a technology and a metric that would apply? How about if you're involved in developing new types of housing for aircraft? What kind of metrics do you think? If you're an aeronautical engineer and you're designing a wing for an aircraft and deciding what materials you're going to use, what kind of metric do you think you might use there? Anybody? Weight. Yeah, weight and dimension. Weight would be a key one, wouldn't it? You know, if you're looking at metal alloys and things like that, weight is a critical dimension. Any other technology and a metric that might apply? What are we using? How about in just the internet, you know, connectivity? What kind of metric might you measure there? So computers, your laptop. So what metrics would you measure in a laptop? Anybody? If you're looking at a laptop, what are you looking for in a laptop if you're buying a computer?
Screen size.
Which?
Screen size.
Yeah, it could be screen size, a screen size that you can physically support, because you'd imagine if a screen got very big, then you're going to have problems with the breaking. And what other kind of key technologies or key performance metrics would you have on computers?
Memory.
Memory size, yeah, absolutely.
Speed.
Speed, yeah, those are the types of things. And what do they say? What's the law in the electronics industry that memory size doubles every decade or something like that? So that there are standard kind of laws that apply, or there are standard processes or development curves that have applied in different industries. So if you're looking at the S-curve, you need to decide on the performance metric. You need to collect data about it, and then you need to know what stage your technology is at, you know, where you're at with a particular technology, whether it's something new, whether it's something that's rapidly evolving, whether it's something that's limiting out. Things like kind of mobile communications, what stage do you think they're at? Your phones, iPhones, different types of devices like that. If you think of the S-curve, in that whole area, you know, talking about mobile, kind of personal computing, mobile communications, where are we at here? Is it in an embryonic stage? Is it mature? Do you think it's mature?
High growth.
Hmm?
Yeah, high growth.
I would reckon it's on high growth. If you look at it, if you think about all the advancements that are happening in terms of kind of personal communications technology, you know, Apple are coming out with new versions of things constantly. Their competitors are all catching up with them. There's all sorts of stuff about patents and who's using whose technology. We're definitely in a growth area there. Now, in a while, you would expect what will happen is that a couple of things will happen that tend to happen with technologies. The first thing is that the technology, you'll hit, you know, in terms of different performance criteria, and you'd obviously have more than one criteria, you'll hit a maturity level. You know, whether it's in terms of, say, in that whole space, one of the metrics there would be reduction in size, you know, being able to make things smaller and smaller. Another performance metric there might be energy consumption. So you need devices that will use less and less energy. There's no point in coming out with a new phone if it'll only work for 2 hours without having to charge it again. So there's a technology in terms of batteries there. The screens and screen definition would be another performance technology. But most of those technologies are actually going through high growth at the moment, aren't they? You know, people are coming out with new versions of things. So you would expect within, you know, the next couple of years, and you don't know how long this is, that those technologies are going to mature. And they will stabilise, so we will get as good resolution as we can get, and there's not a huge amount that they can do to get it better. Or in terms of power consumption, you know, they'll come up with a technology that is about as good as it can get. The other thing that's likely to happen, that happens in markets and with technologies, particularly this kind of thing, is that the market will settle on something. So the market will decide this is the format that we use and that we accept. And that's another thing that will limit kind of innovation in a particular area. So it's something worth looking at over the next couple of years. You would expect at whatever time frame that the number of new phones and different types of phones will start to become limited. And that you'll start to the market will settle on a technology and settle on a particular format or a standard for using it. And that's typically what happens. And next week I might talk to you briefly about, there's a very good example of how markets settle on particular formats or set standards in terms of typewriting and the QWERTY keyboard. So I'll go through that. I'll bring along a paper and I'll go through that next week with you. But technologies typically go through phases like this. They go through phases of change and then they standardize and they kind of fix. So if you think of, say, when the phone was initially invented, for a long time we just had phones. In fact, we had dial phones instead of one in my attic, you know, and households then everybody had a phone. And you kind of thought at the time that was as far as that technology could go. And now all of a sudden now we're into mobile computing and mobile communications, and that is now at a very high growth area. But at some stage in the future, that will just become the standard. Everybody will have some kind of mobile computing or mobile communications, and then there'll be another change, and it'll be something different and something new. But typically, I suppose what I'm saying here is technologies are going through these kind of curves. And for any technology, and certainly say the projects that I've given you, it's worth thinking about these and what are the key technologies in the areas that I've said to look at, and where are those key technologies at the moment. So whether it's entertainment or transport or whatever I've given you to look at, what are the key technologies and where are they at in terms of S-curves. Okay, that's technology S-curves. Any questions on that? No? Okay. It's a useful concept to have. Back to kind of technology road mapping and forecasting. There are basically two ways that you can go about predicting technologies. First is planning, which is where you kind of have a goal and know what your technology is, and you're trying to forecast a market, assuming there are opportunities. It's quite deterministic in that you can say this is how much we're going to do with the market. It's convergent in that your problems, as you start to solve your problems, they become smaller. That's what it means there by it saying it's convergent, and it's very customer driven. So if you have an existing technology and you're deciding how are we going to use it, it's something that's proven, you're talking really about technology planning. What are you doing to plan your technology? On the other hand, another thing that companies need to do is to look at technology forecasting. Where are things going that are different? What are we going to do that's entirely different, that's looking at things in different ways? Much more of a technology focus, much more about looking at opportunities and open-ended, and divergent in that the more you find out, the more you realise you don't know. So those are divergent type problems that are much more bigger and kind of blue skies type problems. For current developments seeing where I'm going. Yeah, in technology foresight, things like globalization, and it's something that, it's becoming the world is becoming increasingly global. You're buying products from all over the place. Recognition of different systems of innovation, and again, that's relatively new. That the system within a company, within a country, certainly for national or regional, the way innovation is managed within a country and the supports that are there is going to have an impact. Other kind of developments, increasing environmental problems, trade-off between kind of portfolio requirements. So there's limited budgets and things like that. So there are a lot of different things that are happening in terms of technology forecasting. Some of the methods to forecast and look at new technologies, and we're going to talk a little bit more in detail about some of the tools. And again, for the assignment that I've given you, have a look at some of these things. Okay, so I've asked you to try and predict the future of a particular technology. Are there experts you can talk to? You know, are there experts out there, you know, somebody's uncle who's working in a business or whatever else? Are there experts that you can get opinion? And when people are forecasting technologies, they call on experts, people who know a bit more than other people. Scenario building, so the notion of kind of bringing people into, you know, the way sometimes companies will bring people into kind of almost a futuristic setting. So trying to build up a scenario, a what if, you know, sitting around a table and trying to think, well, what if it was like